Alright, well, happy Easter everybody. I hope you had a wonderful break. I know mine was too short, but they always seem to be. So, going on with our Section 3 notes. We're going to take care of Section 3 today. If you need to, or when it comes time to study for your test, which will be sometime at the end of this week, beginning of next week, you can go through and look at all the sections of notes, and that will be your first place to start studying. It'll help you remember some of the stuff we talked about. Our objectives for today. We're going to identify how movements of plate tectonics change the Earth's surface, summarize how movements have influenced the Earth's climate and life on Earth, and describe a supercontinent cycle, how it happens. So the first thing, we're reshaping the Earth's crust. We're going to start with rifting. Rifting is a process by which Earth's crust breaks apart. Heat builds up underneath the crust, and as it builds up underneath the continent will separate. We talked about that already with Africa, where they are separating now, or it's separating now, excuse me. And I joked about the fact the Lion King was filmed there because it's supposed to be in a valley, a rift valley. So, slow movement of the plates over this changes the size and shape over the years. As they move, they will change shape a little bit and look a little different than they do millions of years from now, as erosion and other parts of it take care of that. All the continents that exist today contain large areas of stable rock called cratons. The cratons that are older than 540 million years old. And the rocks in them, when the rocks are peeled away and the cratons exposed, that's called a continental shield. And the shield fits right underneath the continents, and you'll see more of that. There's a picture in the book, I believe, that shows where those shields are. One way they change shape, obviously, is breaking apart, and we've already talked about that with that process of rifting. A terran is a piece of lithosphere that has a unique geologic history, and is part of the bigger part of the lithosphere, like a continent. They change not only by breaking apart, but they also consist of cratons surrounded by a patchwork of terrans. So you get these terrans that are added to it. When they converge, plate boundary carrying a terran subducts under a plate being made of a continental lithosphere. It's scraped off, so you have one plate going underneath the other one, and as it goes underneath, it slides through here, and there's stuff that's scraped off from this plate onto the upper plate, and it sticks to it. And with those that stuck, the terrans are scraped off, and they stick to that new plate, so it actually adds material to the plate. That has another word that you're going to talk about in just a minute, which is right here. So right now, pause your video. It should be pretty obvious because I just gave you the answer. And then come back when you're done. Alright, here's your answer. As one's being subducted under the other one. Islands are the land features of the subducted plate, underneath, are scraped off and become part of the overriding plate. That's called accretion. And while accretion is one way that a continent can change shape, it can add more material to a continent. Our climates are a result of those movements. As the continents move, say, for instance, across the Atlantic Ocean, as the Atlantic Ocean gets bigger, there is a current right now, the mid-oceanic or mid-Atlantic current, that carries warmth over to the North American continent. If that current, as the Atlantic Ocean gets bigger, that current's going to change. As it changes, it's going to change the way moisture and heat flow around the world. We have ice that once covered most of the Earth's continent, so for ice ages, and as continents drift around the globe, however, global temperatures change and some of those ice sheets melt off. As mountains form, different organisms are separated. When they're separated, new species may form. For instance, Australia, where a lot of excuse me, we have a lot of marsupials form, whereas we didn't have marsupials form in a lot of North America. There's a possum and a few others. I think possum's the main one. But down in Australia, which was separated completely by a rift along the way, you get kangaroos, you get what are the smaller kangaroos? I forget their names. But you get all those other marsupials that didn't occur here in North America. All right, supercontinent cycle. So you have supercontinents which form and break apart over millions of years. So it creates, gets together, separates, creates, get together, separates, and it's going to happen again. Those continents will all form together to form one giant continent again someday, way beyond our lifetimes. And when it does, it will heat up and break apart again. The last supercontinent was Pangaea, 300 million years ago, and it began breaking apart about 200 million years ago. I'm going to pronounce this wrong, but Pathalassa is a large ocean that covered the Earth. So you have Pangaea in the middle. The rest of the Earth was ocean, and that was Pathalassa. We can get kind of what it looked like throughout history because we look at all the different evidence. We've talked about that already for continental drift, but you have geologic evidence, you have climate evidence, you have the different mineral deposits, you have mountain ranges, you have all these things throughout time that we can put back together to say, okay, this went together with this. Eventually, when those continents broke apart, moved to where they were, then they kept moving and they ran back together and formed a supercontinent. And again, like I said, just like it will happen again in ours. Right now, North America is moving towards Eurasia, and eventually they're going to collide. India is already slammed in there. Antarctica is moving, and eventually it'll move back up and be a part of it again. Over time, this is called the supercontinent cycle. As the movement of plates towards converging boundary cause continents to collide, because neither continent subducts beneath the other, the plate boundaries become inactive. So in other words, they hit together, and you get mountains form, and then they stop. And as more and more collide, they form a supercontinent. Then as it gets warmer underneath the continent, you get a rift to form, the supercontinent starts to break apart, and the continents will move back again. They repeat this over and over, so hopefully you get the idea. Over 300 million years ago, as I said, Pangea formed. We have mountain ranges such as the Appalachians down south, which I just drove through. The Ural Mountains formed during that collision and created Pangea. And the Tethys Sea cut into the eastern edge of Pangea. So the Tethys Sea you're going to hear more about eventually if you were to go on with Earth science, talking about the evidence that came from the Tethys Sea. It was a shallow body of water. And when I say shallow, 300 foot, 400 foot deep compared to like the ocean, which is miles deep. And then Pathalassa was already around. We just talked about that. Here's a picture. I don't know if it shows up on yours. Hopefully it will. There's Siberia, North America. This is 450 million years ago. Earth's continents were separated as they are today. This is 225 million to 200 million years ago. Pangea had formed. It was beginning to break apart. So we had Pangea. It broke off into two continents, Laurasia and Gondwanaland. No, I'm not making those names up. And here they are. 200 million years ago, during the Mesozoic era, Pangea began to break into two continents, Laurasia and Gondwanaland. Laurasia became the continents of North America and Eurasia. So we have those together. We know where they were. Gondwanaland became the continents of Africa, South America, India, Australia, and Antarctica. So here's 160 million to 140 million years ago. Two continents, the Gondwanaland and Laurasia that we just talked about. Notice already you can start seeing where the continents formed that we know today. Slowly the continents moved to their present direct position. As they drifted, they collided with terrains and other continents. New mountain ranges like the Rocky Mountains, the Andes, the Alps formed, and tectonic plates motion causes new oceans to open up and others to close. We have a couple along the Middle East that started to open and stopped. The Black Sea, the Red Sea. I believe the Red Sea is still opening. The Dead Sea is not. And here's our current location. They're moving. This is almost current. I'm sorry, 70 million to 50 million years ago. Notice how they're still moving to where in red we see where they are today and what we're used to. Okay, what modern continents formed from Gondwanaland? Again, you can pause. Alright, there you go. South America, or Africa, South America, Antarctica, and Australia. India was also part of Gondwanaland. They say it was a subcontinent because it moved along on its own. It was all by itself for a while until it collided with with Asia and became. That's what helped form the Himalayan mountains, which are still growing today from that collision. As they continue to move, which they are, Earth's geography is going to change again. We predict that 250 million years, the continents will come together again to form a new supercontinent. So 250 million years from now, there will be another supercontinent. And this really has nothing to do with what we're talking about, so I thought it did. So when that new one forms again, you get the heat build up, and eventually it'll break apart and form new continents, and they will move to different spots in the Earth. This is actually an earthquake chart that shows depth of earthquakes. Why it's in this chapter, I don't know, but if you see it, the idea is that the depth of earthquake. We're going to talk more about earthquakes later, but you notice where most of the earthquakes are shown, and that is because that is where the Pacific plate is being subducted underneath the South American plate. So you're getting all those earthquakes and volcanoes that happen along that edge. We'll talk a lot more about earthquakes in the upcoming chapters. Again, I hope this video helps you. If you have any questions, come to class tomorrow and ask them, please. And when you, again, before we're going to take the test, it'd be in your best interest to watch these again and make sure you go over the stuff that we talked about. All right, thank you.